Now we have the fourth case in which both numbers are negative. So here let us perform the arithmetic operation minus 5 minus 9. So here we will convert it into this form, minus 5 plus minus 9. So here minus 5 and minus 9 will be represented in 1's complement form. So the usual process, 7. So we are using 8-bit format. Okay, so first we have plus 5. Okay, minus 5 I know, but first we will take 1 plus 5, express it in binary form and take the 1's complement to get minus 5. So plus 5 will be 4 plus 1. So here it is 2 to the power 2 and 2 to the power 0. Here will be 1, remaining will be zeros. Okay, then we have plus 9, which is 8 plus 1. So here 2 to the power 3 and 2 to the power 0. Okay, remaining they are zeros. Okay, now minus 5. 1's complement of plus 5. So in place of zeros, 1's, in place of 1, zeros. 1, 1, 1, 1, 1, 0, 1, 0. And minus 9, it will be 1, 1, 1, 1, 0, 1, 1, 0. Okay, so now we'll perform the arithmetic operation. Okay, so minus 5 is 5 1's, then 0, then 1, then 0, and minus 9 is 4 1's, 0, double 1, 0. Okay, so now we'll add them together. So this is minus 5, this is minus 9. So here it is 0 plus 0, 0, 1 plus 1, 0 with a carry of 1, 1 plus 1, 0 with a carry of 1, 1 plus 1 again, 0 with a carry of 1. So here 1 plus 1 will be 0 with a carry of 1, that 0 will be added to 1, it will become 1. Same thing here, 1 plus 1, 0 with a carry of 1, 0 plus 1, this will be 1. 1 plus 1, 0 with a carry of 1, that added with this carry 1 will become 1. Same thing here, 1 plus 1, 0 with a carry of 1 less. So this final carry, it will be added to the LSB. That is the concept in 1's complement. Always remember that in 1's complement, the final carry which is generated, it is added to the LSB of the result. So we have 1, 0, 0, 0, 4 1's. Okay, now this is the 1s complement binary representation. Now we have to convert it into decimal form. So here minus 5 plus minus 9, that is equal to minus 14 in decimal form. So let's see if it is correct or not. So 1s complement to decimal conversion, the concept is, if you remember, this is the sign bit, it is 1, so it is a negative number, obviously it is negative minus 14. So what we'll do, we'll attach a minus sign to this MSB sign bit, a negative weight, and the remaining will be positive, and we'll do the weighted summation. So it is minus 1 into 2 to the power 7 plus 1 into 2 to the power 6 plus 1 into 2 to the power 5 plus 1 into 2 to the power 4, all are zeros, remaining 3 zeros, and then the last bit position 1 into 2 to the power 0, and to the final result we'll add a 1. So it is equal to minus 128 plus 64 plus 32 plus 16 plus 1 plus 1 again. So it is equal to minus 128 plus 64 plus 32 is 96 plus 1612 plus 113 plus 1. So it is equal to minus 15 plus 1, which is equal to minus 14. Yes, both sides they are matching, so it is the correct result. Okay, so this is the 1s complement arithmetic of both numbers which are negative. So most commonly you will not find 1s complement arithmetic used in digital circuits, but this is the base to understand 2s complement arithmetic. So we'll discuss 2s complement arithmetic in a separate video. Okay, so this is